Hello everybody, I'm Dear Kharma, and this is my first ever math tutorial. Today I'm going to be walking you through the Emperor's problem, which I learned in my proofs class at college. This problem uses some heavy logic as well as the power of contradiction, and I can't wait to show it to you. Without further ado, let's get right into it. So here's the problem. The Emperor's daughter had 3 boyfriends and was unable to decide which to marry. The Emperor said to the boyfriends, "I have 3 gold crowns and 2 silver crowns. I will put a gold or silver crown on each of your heads, and the one of you that can tell me which crown he has will take my daughter in marriage. If any of you guesses incorrectly, you will be banished from my kingdom." The first boyfriend looked around and was unable to tell which crown he had. The second boyfriend did the same. The third boyfriend said, "I have a gold crown," and he was correct. Plot twist, the third boyfriend was blind. How did he know? So, here's what we know. There's 3 boyfriends with 3 gold crowns and 2 silver crowns to be chosen from. We know that boyfriend 3 guessed his crown correctly and that he was wearing gold. One way for this to happen is if boyfriend 1 and 2 were both wearing silver, because then that means that there's no more silver crowns left, and so boyfriend 3 must be wearing gold. However, boyfriend 3 is blind, meaning this can't be the way that he figured it out. So we have to find a different way, a different logical approach that boyfriend 3 used. Well, while boyfriend 3 is blind, 1 and 2 are not. Meaning, if boyfriend 2 and 3 were both wearing silver, boyfriend 1 would know there's no more silver crowns, he must be wearing gold. On the same note, if boyfriend 1 and 3 were both wearing silver, boyfriend 2 would see this and know there's no more silver, so he must be wearing gold. However, according to the problem, neither of these scenarios happens. So what does this mean? And this means that 1 and 3 cannot both be wearing silver at the same time, and 2 and 3 cannot be both wearing silver. Well, to proceed, we're going to use this proof tactic called proof by contradiction. And what that means is that we suppose the opposite of reality happened, and we find a contradiction. And once we find a contradiction, that proves that the original case is true. So, to prove our contradiction, let's suppose that instead of wearing gold, boyfriend 3 was wearing silver. What does this mean? Well, it means that number 1 cannot be wearing silver, and number 2 cannot be wearing silver. Because if number 1 was wearing silver, number 2 would know he's wearing gold. If number 2 was wearing silver, number 1 would know he's wearing gold. And as we know, neither of these scenarios happens. Well, you can also deduce that number 1 and 2 know these facts, because they're all perfectly logical. So, number 2 knows that if boyfriend 1 doesn't immediately know his own crown color, then that means that boyfriend 2 and 3 are not both wearing silver. And since boyfriend 2 knows boyfriend 3 is wearing silver, boyfriend 2 knows that he himself is wearing gold. But this doesn't happen. Similarly, if boyfriend 2 looks around and doesn't know his own crown color, that tells boyfriend 1 that he and number 3 cannot both be wearing silver. And since number 1 knows number 3 is wearing silver, number 1 knows that he himself has to be wearing gold. Back to the original problem, none of these scenarios happens because we learned that boyfriend 1 and boyfriend 2 look around and still can't tell what they're wearing. So, this is a contradiction, because if number 3 has a silver crown, then in each scenario, either boyfriend 1 or boyfriend 2 knows what crown they're wearing. This doesn't happen, as we explained, because in reality, neither of the boyfriends can say for sure what color they're wearing. So, this is a contradiction to the fact that they don't know. Because again, if 3 was wearing a silver crown, then 1 or 2 would know. So, because we found a contradiction, that means that 3 can't be wearing silver, he must be wearing gold. And that is the emperor's problem. I hope that you all learned something new today and that you enjoyed my walkthrough of the emperor's word problem. I will say that these are by far my favorite types of proofs word problems to solve, because I love the logical leaps and bounds that you have to go through to figure out the answer. Be on the lookout for more math tutorials or card reviews to come, and I'll see you next time.